let's start our session today. Let's see what we can do first. Let's go to ChatGPT, and I was basically having a query today, which was, let me just sign in first. Let's say I have a program. I'm going to go into VS Code. I was testing some assembly code today, but let's just go to Python first. I have it here. Algorithms. No, nothing here. Alright, so let's create a Python file which will say test.py. This is just a normal Python file. My query was like this. Let's say I have a simple program. So let's say x, which is an integer, equals 5, and y, which is also an integer, equals 10. Okay. So let's say I print the value of x plus y, and if I run this program, if I run this program, I'm gonna get 15, right? So here I have two variables, two integers, and I can also make a program which is it's the same. Let's say a, which is an integer, equals 3, b equals integer, equals 7, and instead of printing a plus b, we are going to take an extra variable, which is a result, which is also going to be an integer. So for mentioning the data type, we can say result int, and instead of directly printing a plus b, we are going to print the result. Now my query was this, that does the second program take any extra space because of the result variable? Now in theory we can say that the second program, it takes extra space because there is an extra variable, but I was thinking that the first program also has the x plus y, the value must be stored after being calculated by the the ALU into the RAM. So let's just ask ChatGPT if there is any difference of space complexity in these two programs. Let's just query. So I'm gonna write a prompt. Imagine you are my computer science tutor, and I asked you a question that because the second program uses one extra variable, does the two program have different space complexity? So the short answer is no. Both programs have constant amount of memory, which means their space complexity is off one. Yeah, that makes sense because it doesn't as the program goes, it doesn't make any extra variables. So it's really using a fixed amount of memory. Yeah, that's okay. Now my next question would be that does the second program take up more space than the first one because it uses one extra integer result? So let's just say if ChatGPT says yeah, technically. So the second program usually is slightly more memory because it stores one extra integer. Alright, so my next question would be that if it uses one extra integer, then when we are adding the two variables in the first program, so when we add the two variables in the first program, its value is calculated by the ALU, then it must be stored somewhere in the RAM before being printed, right? So doesn't it take up the same space as the second program? So let's see. You're thinking in exactly the right direction, tracing what actually happens in the machine. That's where the things get fun. Yeah, that's true. So let's unpack this step by step. And the CPU, specifically the ALU, which is the arithmetic logical unit. So the arithmetic logical unit, it's in the name that it like calculates all the values. It does arithmetic calculations. This computes the value of x plus y. Now here's the interesting part. Does the result get stored in the RAM as a separate variable? Not necessarily. Okay, maybe it's not stored in the RAM as a separate variable, but it's still stored, right? So it should take up like some space in the RAM, right? In most languages, especially interpreted ones like Python, the expression's result may exist temporarily in CPU register, or stack temporary value, or as a short-lived object in interpreter's evaluation process. But it's not stored as a named variable in RAM unless you explicitly assign it. Okay. Without the assignment, the program is allowed to compute the result, pass it directly to print function, let the temporary value disappear. Alright, okay. So temporary exists, but it's short-lived, non-persistent, not a named variable. That's fine. And some stored in registers, not RAM. Alright, okay. Meanwhile, in the second program, this is stored definitely in RAM. Alright. In the second program, some must live longer because the code reference. Alright. So my next question would be, okay, maybe the first program uses the register to store the calculated value instead of the RAM, but still doesn't it take up the same amount of space? Certainly a subtle but important distinction, and it's one many students wrestle with. Alright, let's pin it down. You're asking, even if the temporary value lives in a register instead of RAM, but RAM isn't memory, instead of RAM, isn't memory still memory? Yeah. Doesn't it still take space and therefore match the second program? Yes, both programs must allocate some place to store the computed value temporarily. But no, that doesn't mean they use the same amount of memory in way we measure program space usage. Alright, here's the key idea. There's a difference between computational workspace and persistent program state. Okay, so imagine a factory. The workspace table is CPU register, the storage shelves. Yeah, alright. Okay, so what ChatGPT is saying is that we measure space or space complexity, like how much we are taking up space in the RAM. That's the measure. So if we take up space in registers, it's not really, it's still taking up space, but it's not really how we count that space. That's what ChatGPT is saying, I think. Okay, so let's just tweak these two programs a bit and let's have some more fun. So, alright. Let's say there is a variable called a. This is an integer and this equals to 1. Alright. Let's run a for loop, which is for I in range 10. Yeah, 10 is a good number. And so we're gonna print a plus I. So this is a pretty straightforward loop, and what's going to happen is that it's going to print first 1, then 2, then 3, then 4, like this up till 9, I think, right? First value of I will be 0, then 1, then 2. Yeah, so I think it's going to print up till 9. Let's look at how this program behaves. So let's just run this code. Python. Sorry, did I make a mistake? Code. oh no, it gives from 1 to 10. Did I make a mistake? For I in range goes from, oh yeah, of course, yeah, A is 1, so yeah, it prints from 1 to 10. Alright, and now we're gonna have we're gonna have the same like program where instead of A we're gonna take B. This is also an integer and it's going to have a value of 2. We're gonna run the same for loop for I in range 10. Sorry, this would be 10. And we can say print, instead of saying this, we can say result equals to B plus I. So it's the same program as before, except we're just taking an extra variable result, right? And now we can print result instead of printing this expression directly. Now let's run, we don't need to run both of these programs, but still, okay, let's run it. So you can see this prints from 1 to 10 and this prints from 2 to 11, right? I should have like printed in a much better way, but okay, that's not why I'm here. I'm here to ask ChatGPT this question, that now both these programs are using for loops. So for n digits, okay, let's just ask, so now is there a difference between the space complexity? And I'm assuming that there will be no space complexity difference because it's still creating one extra variable, right? Well, let's just ask. I'm curious about it. These two are more interesting than the original samples, yeah? No, the space complexity is still off. Yeah, okay. So, yeah, my query is kind of resolved right around here. So today, what I'm gonna do is basically write some code, and we're gonna write like the codes in 4 different languages. First, we're gonna start with Python. Next, we're gonna go to C++, then C, and then finally, I think a very interesting one, which is assembly. So yeah, we're gonna do assembly today, okay? So I'm gonna take help of ChatGPT because, like, here's the thing. In today's age, you have to take help of ChatGPT. Gone are the days where you needed to memorize programming syntax. And I'm basically gonna show you how to do it. Alright, so let's just start with Python. Here I have this test.py file. If you don't have Python set up in your computer, I'm also going to show how to do it in a web browser. Alright, it's going to be very easy. Let's just say Python online compiler or interpreter. My keyboard is not functioning like how it should be, because when I press the T key, it's just double typing. So double T. That's why I'm having some problems typing. So this is, I think, the most well-known compiler, interpreter, whatever you say. And we are going to write our program in VS Code first. Then we are going to paste the code in the online compiler. Alright. So okay, let me just rename this file. Let's rename this file to hello.py. Damn, my keyboard is not working. Yeah, hello.py. Okay, so what I'm going to do is I'm going to tell you how to start writing programs. Right? If you have never written a program before, you can start here. Alright. I know starting programming may be a little not hard, but it's a little scary. I've been there, and don't worry, I'm here to guide you basically. So we're gonna start with the most basic program that we all do, which is hello world, right? So in Python we write print, and then we write this weird syntax, which is like in other languages we call words or letters. In coding languages we call it syntax. All right, so in English words, in Bengali words, in Hindi words, in French words, in German words, letters, characters, whatever you say. But in programming languages like Python, C, C++, Java, we call it syntax. All right, now we write this weird syntax, and I'm going to tell you what this means, this bracket sign means. So this is known as a function. Whenever you write brackets after something, it denotes a function. All right, so let's just write some few functions for fun. All right, so let's say eat, right? Eat is a function. And let's say drink. Okay, is drink a function? No, because we have not given that bracket syntax, right? But now drink is a function. Okay, so yeah, let's just say we are going to write 5 functions that we can do as humans. All right, so 5 functions that we can do, right? Or that humans can do. So number 1 is what do you call it? Walk. Walk is a function that humans do. Okay, yeah. So AI is showing me the what we can do as humans, right? So there is talk. Yeah, we can talk as humans. There is eat, definitely. There is sleep. Okay, and what is this there? Okay, we can think. Yeah, we can think. That's the most important one, right? So like all of these are functions, and why do we call these functions? For a very simple reason, because they have this weird bracket syntax. Once I remove them, now think is not a function, but once I add them, now again think is a function. So now you must be wondering what's going on. Like, why this removing these brackets make it a function, not a function, and adding this bracket make it a function? We are going to study functions in future, but right now you just need to know that yeah, brackets mean function. Say it again with me. Bracket means function. And you know what? Computer science is not hard, but we make it hard. All right. Me, the other guys who have invented programming, who have like made these languages, they make it unnecessarily hard. All right. So these brackets, we could have called this brackets, right? But they don't call it brackets. They call this with a special name, parenthesis. Isn't this hard? Like, this is just unnecessary jargon. We could have called this brackets, but we still call this parenthesis. And you know, I say to all my students that like computer science, just this syntax, this parenthesis, they make you sound cool, you know. Sorry. Like you're talking to someone about computer science. You know, I learned all this syntax and I know how to write a parenthesis. Like, you don't know how to do shit, but still it just sounds cool, right? So yeah, that's all. Now print is a function, and function, it's in the name, right? Like it does something. It's a function, right? So the print function, what it does is it prints. So you can tell print to print something. So let's say you're telling print to print hello. Okay. Now we are not going to run this program here. We're going to copy this. We are going to paste this in our online compiler. Again, I'm going to show you once more how to open this. You already know still. Python online compiler. You just open this one, GDB, and yeah, like just write your code here, paste it here, and just run this. You can see that it prints hello. So the job, the function of print is to print. It's that simple, right? So let's just have some more fun and let's just print some more things. So let's just say my name is Kingshuk. Right? Yeah, let's just print this. Or we can say that I'm a man. Right? We can print anything here. Now, this was the first program that I wrote, not in Python. My first ever program I wrote in Java. Alright? And back in those days, what used to happen was that you only learned one programming language and you learned it for like years. After that, if you wanted to, you would switch. Generally, nobody switched because they used to know their language so well. But those days, I feel those days are gone. Now you need to learn at least 3 to 4 programming languages, and like AI has come to help you, right? So it's not that hard. And yeah, I'm going to be there while you're learning. Okay, so let's just start with hello world. Let's just print hello world. And again, to understand the syntax is that you are printing using the print function. The print function has a job to print, and it's printing hello, right? Okay, quick questions. Let's show the pent. Okay, question number 1, which is, what is print? What is print? Print is a function. Question number 2, why is print a function? Why is print a function? Because why is print a function? Because print has these brackets at the end, which we call, this is our next question basically. What are the brackets called? What are the brackets called? So you already know that the brackets are known as a parenthesis. In programming, we don't call it brackets, we call it parenthesis. That's how it goes. I'm sorry, the jargon, it's hard to learn. Once you learn it, it's gonna sound so cool. You're gonna feel like a hacker. All right. Now, last question. Have you noticed that while writing hello world or anything, I have constantly used these 2 double brackets, not double brackets, these double colons, right? So what are these double colons? What are these double colons? So they represent that we are writing a text. Okay, so listen, the print is a function, right? And what it does is it prints, right? So when it prints, it asks for something to print, right? So here's the print function. You're saying, man, print function, print something for me, all right? And the print function just says, okay, what do you want to print? And I'm saying, okay, let's just make me print hello world. Okay, so if I write hello world like this and run this program, you can actually see that it's giving me an error. It says, what is hello world? I don't know what is hello world. So you have to tell it that actually print hello world is a text. It's a text, print it. See, it prints hello world. So see, we are very intelligent creatures, and like we don't credit ourselves as much for how intelligent we are. But Python compared to us is very dumb, right? We can see hello world and we can instantly think that yeah, it's a text. Like what's so odd with it? But Python, it doesn't know. It doesn't know what hello world is. Is it a text, a number, like something else? It doesn't know. So what happens? It tells us that I'm not going to print hello world until you tell me what it exactly is. And the moment you tell it that it's a text, it prints hello world. How do you tell it it's a text? By wrapping it in double quotations, double colons, whatever you say. I think it's quotations, not colons, I'm sorry. So now, next question. What are double quotes? And so it means whatever we are writing inside double quotes. Oh, I'm messing up the spellings here. Whatever we are writing inside the double quotes is a text. That's what the double quotes mean, right? Okay, last question. Last question from Python. Alright? So, last question from Python is that what? Let me just write this here. What is a text? What is a text called in Python? It has a special name, again a jargon. A jargon is a special name. Like, think of jargon like this. You go to a hospital, you meet a doctor, and you ask the doctor, what's wrong with me? Now, he's not going to say, okay, there's nothing wrong with you, just a simple chest pain or something. He's going to use jargon. Your aorta has this problem, this tissue is damaged, this vein is... you're meanwhile thinking like, what is he saying? Just like saying my terms, man. I can't understand shit. So that's basically jargon. So we programmers use our own jargon, and we don't call text in programming languages. We don't call it text. We call it a string. Okay. So yeah, when we are gonna say what is hello world, we're not gonna say that this is a text. We're gonna say that this is a string. Okay. So Python, print hello world. Python will ask what is hello world. Print will ask what is hello world. You're gonna wrap it in double quotes. You're gonna say, okay, this is a text. Not a text, a string. Right? Text is a string. It's what we call it in Python, right? Okay. So yeah, Python is done. Next, let's open up a compiler of C or C++. Let's just open C++. C++ online compiler. Yeah. Now in C++ you can instantly see that the code is going to be a bit longer. Okay. Let me just write the code first of the same thing. We're going to print hello world. Okay. So I say hash include iostream .h. I think that is the correct syntax. I haven't written C++ in like 5 years. Okay. So forgive me if I do something wrong. I may have to check with ChatGPT. So next, let's say int main and return 0, and this is going to be like just what is going on. You're gonna think this, but okay, let's just we're gonna break everything down. Okay. Std cout hello. Let's see if this runs. It says compilation terminated. Maybe this is IOStream. Yup. We have successfully written our first C++ program. Okay. And what does it mean? So you can see that writing in Python was just one line. Writing in C++ is already 1, 2, 3, 4, 5 lines. And there's just so much text here, right? What is in, what hash include, what is IOStream, what is std, what is cout, what is the, okay, I can understand this part, right? I can understand hello world, because yeah, hello world is a text. How can we understand it's a text or a string? Because like it's wrapped around in double quotes, right? Then there is this semicolon, the return 0, what's going on? So yeah, C++ code is hard, man. C++ code is hard. However, it's really fast. That's why we learned C++, because it's freaking fast. Okay. So, okay, let's just start from the start. What is this hash include? And what is this IOStream? So, in C++, we have something called header files. Okay, and trust me, you're not going to understand what header files are. Think of it like this, that you're like hammering a nail, right? You're hammering a nail. Now, to hammer that nail, you actually need the hammer, right? Can you hammer the nail without the hammer? No, right? IOStream is that. IOStream is the hammer. It's a tool that helps you to print. If I remove the IOStream from here, we have written the exact same code, but it's not gonna print, because to print you need the IOStream. It's like a tool that you need. Just understand this part, okay? Next, what's this hash include then? This is simple. Hash include means let's just include this tool, okay? We are going to use this tool. That's what it means. Okay, next, int main. What is int main? So yeah, okay, you're gonna learn a new concept right here, and it's gonna be fun. Okay. So every program has a main function in C++. In C++, every program has a main function. What does that main function do? It starts the program. It starts the program. Okay. Let me ask you a question. What is the first line of the program? What is the first line of the program? Is it line number 1? No. Is it line number 3? No. See, this main function, you can see it's a main function, right? Because after main, there is brackets, there is parenthesis, right? So main must be a function, right? So is this the first line of the program? No, the main starts the first line of the program. So after main is the first line of the program. What is after main? Which line is after main? This line is after main. So this is the first line of the program. Got it? That's why when we run the program, the first thing that prints is hello world, because technically it's the first line. Okay. Next, okay, let's just go to the second line then. What is this return 0? What is this return 0? Okay, can I just say that let's just learn about return statements a bit later. Okay, let's just think of it like this. Whenever we write main functions in C++, we have to write a code at the end which is return 0. Let's just understand this part. We will learn about functions. We will learn about return statements in future videos. Okay. Now, what is the syntax int main? Like, I understand the main is a function, but what is this int and what is this brackets? We didn't have this dirty kind of syntax in Python. What is this? So yeah, it's not that hard to understand. Basically, this is the main function. This signifies the start of the main function. This signifies the end of the main function. See, this creates a block. So the main function is actually this block. That's what it means. Last question is What is int? We will learn about it later. When we learn about functions and return statements, we will definitely learn about what this int is. Okay, let's go to another language. C, online compiler. Alright, how do I write? Oh, it's basically, it has written the program for me. But okay, let's just write this one more time. So hash include. Last time we wrote IOStream, right? In C, we write stdio.h. Then we basically do the same thing. We say int main, then the function block, then we write printf hello world, and we give a semicolon. Oh, I forgot to tell you about the semicolon. We'll talk about it. Let's just first see if this program actually runs. Oh, we forgot the return 0. I told you, we forgot the return 0. Let's just see if this program runs, alright? Yeah, this program runs. It gives me hello world. Now, my question is, if this program runs, did you notice that it has a bit different syntax than C++? It's almost the same. There's the include statements, but see, what it's including is different. Here is it's including IOStream. Here's including stdio.h. Okay, it's different, but did you see that even in the difference, there was something in common? For example, see, there's a IO here. See, there's a IO here. What is this IO? IO means input output. IO means input output, which means this file or this tool or this hammer that we discussed, it helps in doing input and output. Same for the C++. This file, this tool helps us do input and output. That's why it's called IOStream or stdio. The full form of stdio is called standard input output. STD means standard and IO means input output. And this is input output stream basically. So they use different tools. Both of the languages use different tools. Or if I use the correct term, they use different header files. But they do the same thing. What they do is they will help in input and output. That's all. Now, did you see that for printing, okay, the main function is absolutely same. The main function is absolutely the same. See, the function block is absolutely the same. Even the return statements are same. Just this print is a bit different, and this print is a bit different. Oh, we actually forgot to talk about this std cout, right? So I told you that std means standard, right? So we are saying, man, we use this IOStream file for input and output. Now, this uses a standard file, std file, which has this cout function, which means output to the, I think let me just check once. Cout meaning in C++. Console output, I think. Cout means console output. Okay, it's not given here, but as much as I remember from my class 11-12 days, cout means console output, okay? So, my throat is hurting a bit. So what's going on is that cout means console output. So output to the console. What do you output to the console? Hello world. And this cout function is inside a file called std. It's not actually called a file, it's actually got a namespace, but okay, let's just not complicate things. Let's just make it easy here. Okay. So in printf, this is hello world. Now what is this doing? See, it's a bit easier to understand. We're using the printf function, right? And then we're saying, okay, what do we do inside the printf function? We print something. How do we know it's a function? Parenthesis. What do we do inside the function? We print something. What do we print? Hello world. What is hello world? A string. How do you know it's a string? because of the double quotes. Or the double quotes, right? Alright. So let's just. Oh, we ran this already. Yeah. So this is how C++ code works. The thing is that you don't need to understand all of this. You actually don't need to understand 50% of it. Now that AI is here, you only need to know like a few stuff. Like in Python, what's going on? What's going on basically? Oh, there's a print, which means some kind of printing is going on. Oh, there is a hello world, which means hello world is being printed. In C++, you need to know, oh, there is a stdc out here, which means something is being printed here. What is being printed here? Oh, there's a hello world being printed here. You just need to know this much because AI is here now. AI is here to help you understand. AI will write code for you. You don't need to understand as much. You just need to know the overall structure. In C++, you see, oh, printf, that means something is getting printed. Oh, there is hello world, so hello world is getting printed. That's all you need to know, nothing else. Now for the last language, which is assembly. I'm not going to do assembly code here. I just like compiling assembly code in my Linux terminal. So let me just open Oracle VirtualBox. Let me open Kali Linux. You don't need to do this. You can open this in assembly compiler online basically, and you will get plenty of compiler which are in assembly. See, there is also JDB. So yeah, you can do this. But I'm going to write an assembly program for Hello World, and trust me, it's going to be very much fun. Okay. So let me see if my Kali has opened up. Yeah, my Kali Linux has opened up. Let me just open my terminal. Let me go to my development desktop, development assembly. Okay, let me see, there is already a file created. Okay, ls x64 cd x64. Let me clear all of this stuff. Yeah. Now let's create a file. Okay, and we are basically in Linux, so the rules are a bit different. I know it's going to sound very complicated, but if it sounds complicated, can you just follow along with me? I promise it's going to be fun. Okay, just write nano and let's just say first.asm. What does this mean? Nano is basically a text editor. In Windows we have what? Notepad or VS Code or whatever you use, but in Linux we have Nano, or we also have Vim, but I absolutely don't like Vim. I like Nano much, like it's much better. Okay, and Vim it's just too much complicated for me. I'm not that high level of programmer, so yeah, Nano is okay for me. So what we're saying ki, okay, use Nano, use the Notepad or whatever text editor to create this file, which is first.asm. .asm means it's an assembly file, and the file name is first. That's basically what it means. There is our empty program, and we can write our first assembly code here. Of course, I don't remember the assembly code for Hello World because I have not written assembly in quite a while. Okay, so let me just go to Google, and let me go to not Google. Let me go to ChatGPT. Let me say write a Hello World program for in assembly. Okay. Let it print it for. Let it like output it. What is he thinking so much about? It's just a basic Hello World program. Okay. All right. Yeah, it is given me the Hello World program. Now, let me just copy this and let me just paste this. Wait, what happened? Yeah, let me just paste this. Now, you can see that writing Hello World in assembly takes How many lines? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. It takes 21 lines of code to write one assembly hello world program, right? And I just want you to admire the abstraction that has happened over the years, that in Python we have just one line printing hello world, and in assembly we have 21 lines for just one simple little message. So this just sounds very complicated. Like, why are we even doing this? 21 lines for just one message. It just doesn't sound like a very good thing to do, right? Not an intelligent thing to do. But here's the thing. After you have written code for 5, 10, 15 years, like I'm writing code for around 10 years, okay? And for a while, Python, C, C++, Java, they all sound very interesting. You learn about class, objects, functions. They're very interesting to learn. But after a while, after 10, 15 years, you start to wonder, okay, but what's actually happening inside the computer? What's going on under the hood? What's going on in the hardware? How am I writing a code, and for that code getting output on the monitor? Because the code is software, right? But the output I'm getting, the output that shows in the monitor is a hardware, right? How am I getting that thing that I'm writing in the software to be outputted in the hardware? And that was just a very, I don't know if I explained it very well, but it just sounded very interesting to me, that I can directly, the most interesting part to me was that I can control a computer that has that has infinitely more capabilities than me in terms of space and time, because it's faster than me, it can store more data than me, and it's a beast, and I can actually tame that beast. I can actually control that beast, and it's kind of a sense of I have power over that. I can do that. That got me a bit interested in writing assembly code, that I can actually see what's going on under the hood. So let's just slowly, steadily, let's just see what's going on. So this is the first line, which says hello.asm, which is the wait a minute, symbol. Wait, aren't this the, what is this? This is not the code. This is the code. That's not the code. ChatGPT, that's not cool. Yeah. So let me just remove all these sections here. These are basically comments, alright? And right now we don't need comments. Okay, so around 15 to 16 lines for one hello world message. So right off the bat, you can see that there are two sections. One is this section data. One is this section text. Okay. So what is this section data? In Python or in any other programming languages, we do not separate these two sections ourselves, but the compiler or the interpreter does this under the hood, which is the data, the variables, anything that are going to be used in the program. We have to write it in a separate section, right? So look at this. This is a variable called message. The message is hello world. Sorry. And why is this 10 written here? The 10 is written because you can see HELLO, 5 characters, comma, 6 character, space, 7 character, 8, 9, 10, 11, 12, 13. Wait, 10 equals new line. Did I miss something? Okay, so the 10 is not the length of this string, which I mistook it. I thought that was the length of the string. They're saying that the 10 means new line. Okay, I'm not really sure about that. Maybe ChatGPT is saying right. Sometimes ChatGPT hallucinates, so we can't trust it blindly. Okay. Now it says message len equals, EQU means equals, $message. This is the length of the string. So what they're doing is this message DB. Okay, I need to understand what this message DB means. What does DB mean? So DB stands for defined byte. Yeah. Assembler directives like DB, DW, etc. are instructions for the assembler or the CPU, telling it to reserve memory and optionally put some initial values there. So in simple words, DB means store these bytes in memory. Okay, this creates 5 bytes in memory containing the ASCII values. This is if you add a terminator, null terminator. This is this. Okay, now it's stored as a C string. All right. Example: age DB21, year. Okay, let me just ask, why 5 bytes? Why 5 bytes? Wow, ChatGPT is thinking so hard. I don't know what's that think. Like, why are you thinking this hard, man? What's going on? Let me refresh this. Yeah, something's going wrong with ChatGPT. Let's just go to Gemini. I'm getting sleepy. It's getting late. Okay, let's just copy this again. Control Shift C. Yeah, let's just. Where's my Google? Yeah, just paste it here. So let's just ask 10. Let's just ask, what does this mean? Okay, what does this line mean? Let's just see. Okay, so yeah, it's pretty simple to understand that EQU equates the message len. This directive defines a constant. It tells the assembler wherever you see message len, replace it with value calculated on the right side. Okay, and key concept: it is not a variable stored in memory. It's a constant value calculated at compile time. That's very important. This is going to get hard for newcomers to understand. But in assembly, what happens is that normally what happens is, we in Python, what we saw was that we wrote print hello world, and everything just Python says, I'm gonna take care of everything. But in assembly, what happens is that you need to say what we are gonna print, like hello world. We're gonna print hello world, which is stored inside a variable called message, and also we need to say the length of that variable. Otherwise, it can't print that. So you need to mention the length of the variable. So it's saying that message len variable is actually not a variable; it's a constant because the length of is constant, right? This will equal to the message, right? It basically means the length of the message. Okay. So let me just see what it does. The $sign represents the current memory address of the assembler right at the specific line. Since this line immediately after string definition message DB, the dollar points to the byte memory immediately after the last character of string. Right. So what it does is message is label pointing to the start of use string hello. Okay. So much going on here. Let's just read it another time. Okay. How the math works. Imagine memory addresses look like this simplified. HELLO and then at the end 10, which means the next line. Okay, the formula is length equals to current address minus start address. Okay, yeah, perfect. So the dollar is at 0x10f. Yeah, of course. So this dollar is where our memory is at currently, and then this message is at the start of the message. So that's why it's subtracting this from this. Yeah, it's pretty hard to understand for newcomers, I know. You don't need to if you don't want to, because assembly is like people start learning assembly after a while learning programming, but if you want, it's pretty fun to do. Okay, so next, so this message length has been calculated, and next is section text. So the section text, right, like how I said in C or C++, the section text is actually the main is actually the start of the program. So in assembly, the section text is actually the start of the program. Okay, and global start, yeah, so it's saying the entry point of the Linux. So yeah, so from just like the main function in C or C++, start is that function or the entry function in Linux, or sorry, not Linux, assembly. And the dot text part is where we write our actual code. Okay, now it's a comment saying write one message length, right? So it's saying move RAX1, move RDI1, move RSI1, move RDI. So what does all this mean? So move RAX1, it means syscall number for write. Syscall, this is basically, yeah, let's just ask Gemini to explain syscall, because I think it can explain better than me. Yes, let's explain syscall. Syscall is actually a call to the hardware, right? So we are going to learn about kernel mode and user mode, all of these things. The big picture, user versus kernel mode. In modern operating system like Linux, your program runs in user mode. It has limited privileges. It cannot directly access hardware like screen or disk or manage memory on its own. The operating system kernel runs in kernel mode and has full control over everything. When your program needs to do something real like printing or printing text or exiting, it must ask the kernel to do it. The syscall instruction is how you make that request. So here's the broad overview. See, you're actually telling to print. Who's gonna print? Monitor is gonna print. Monitor is a hardware. Your code cannot directly control the hardware. Why your code cannot directly control the hardware? Because if your code could directly control the hardware, you could have messed up a lot of things, right? You could have messed up circuits in your motherboard, you could have messed up the CPU, you could have killed your RAM, you could have done a lot of things. That's why intelligent people like Linus Torvald and what was his name who wrote Git, Jason something, I think. Intelligent people like them, they write all the hard stuff for us, the kernel. And what we do is when we want to do something, we request the kernel. Hey man, kernel, please do this thing for me. Please run this program for me. Please print this file for me. And we request the kernel through this, you can say function, or what is this called? It's an instruction. There was a name for it. Error code is called the form right call segment. No. What is syscall called? Let's see what is syscall called. I basically forgot this whole thing because there is a video still. I can still watch it. Wait. I did this video 4 years ago. So I explained the hello world code right? I can watch my own video, okay, to understand what's going on. Because I did assembly back then, and I was quite good at it. But later I left. Okay.
And RAX is one such register. And what is this one? This one has a special meaning. Here, this one means that we are telling our operating system. This one means that we are telling our operating system we want to write something.
Yeah.
This whole code means we are moving the number 1 into the register RAX.
Yeah.
To simplify this, I can show you how the same code might look in a high-level programming language, and same code as writing move 1 telling our 1 I as you. Now we already saw what move means. This 1 has another special meaning when it is being moved into the RDI register. In the second line, this 1 means we want to write something to the console. So in the first line, the 1 meant we are telling the operating system that we want to write on the console. This move message into RSI is in our data section, and we have said that on 10. So what does this mean? You can think of message as just another variable, the variable type. The DB stands for bytes of data, and finally we are writing the message itself, which is hello world. But what is this comma 10? This 10 actually has a special meaning as well. This 10 actually represents a new line character, which means every time this message is called, we will not be printing to the same line again. Instead, we will go to the
next line. Yeah.
The RS. We are moving here. Now, one thing we need to understand here is that we are moving message into RSI register. Now this RSI register is a part of the processor. As I just said, any register is a part of the processor.
Yeah.
But this message is written in our data section. And it is not stored in the processor.
Yeah.
Instead, it is stored in our memory, or what we call the RAM. So we are taking the message which is stored in our memory, and we are moving it to the RSI register of our processor. Moving on to our fourth instruction set, and the last, move 12 into RDX. Now what is this 12? Where does this come from? This 12 is actually the length of the hello world. You can see 1, 2, 3, 4, 5, 6. The space 11. We have a representation for our new line character, which makes it 11 plus 1, which is 12. What we are actually moving is the length of this hello world and the new line character into our register RDX. To put it simply, every time we print something in our assembly language, we also have to pass its length, which is syscall. What this means is we have written all our instruction set, and now we want to call our operating system to perform all those instructions on the processor. So as we saw in our last video,
alright, I got a pretty good idea. It's been a while. Let me just log in again. Okay, so we are moving this one into the RAX register. Registers are something that lives in the processor, and this is the fun of writing assembly, that you have to know everything about the hardware, about the processor, write assembly. That's the fun part. So move RX one into RX, which means we are going into writing mode. We are going to write something, and this is RDI into move 1 into RDI, which means we are going to write on the console, on the monitor, whatever you can say. And move RSI move message into RSI, which means RSI is a register in which we are moving our message, and move RDX message length. So in RDX we are moving the length of the message. Then syscall, and Yeah, why are we saying exit 0, move XOR 60, exit? I need to understand this part because this is not necessary. This is unnecessary code. But let's just see what Gemini says. Let's see. Just ChatGPT. Yeah, so let's just call let me see. Why XOR RDI? You might have noticed this line, XOR RDI. Okay, let's see why we are writing XOR RDI. So it's the same thing, which means it will always, the status will be always 0. Yeah, if you don't know about XOR, if XOR is like a Boolean gate, if it receives 2 of the same inputs, it will always gate 0, which is what's happening here. You might have noticed this line. This is a common assembly optimization. XOR is a register with itself always resulting 0. Yeah, but why are we writing this? It's actually faster than and uses fewer bytes of machine code than writing move RDI 0. Move RDI. Wow, it's actually something that I didn't know. Wow, that is actually fun. Yeah. Wait, let me just.
If we
Okay, that was exact.
that
Okay, now I'm going to run this program here, but
the console, because
yeah, the last 2 things. This is what I need to understand here.
60.
The segmentation falls. Yeah.
Last line of our, then if we
I forgot
read
about that.
/ in 2 seconds. This is a simple fault in our code that we are just going to fix right now.
Yeah.
So first let's understand why is this segmentation fault happening. So let's open our file, which is first.asm. So I'm gonna write nano in a nano text editor, register that we want to write something, and then we are telling the RDI register that we want to, we are passing the length. Operating system doesn't know what to do next. Our operating system thinks that we want to give it more instructions, but we know that our program has already ended.
Okay.
So there is a miscommunication between
I
us
see.
and our operating
Even though we call
system.
this syscall, it
We
still thinks that we
tell
are going
our
to
system
write more
somehow
code
that we
or
have
give it
in
more
our program.
instructions.
We need to write 2 simple lines of code.
Yeah.
We already saw move RAX, which is we are moving something into the RAX register.
So move
What
RX
is
60,
60?
which
Now,
means
as
we
you
are
might
going to
already see that
exit the program.
in assembly code we have a big problem with numbers.
Yeah.
Each number has a special meaning. Each
That is
number
true.
represents something. So in the same way 60 has a special meaning. 60 means we are going to exit our program.
Yeah.
So as we saw, 1 means we want to program something, program. So as we saw, 1 means we want to write something.
Yeah. 60 means we're just gonna exit the
We want
program.
to exit our program.
Yeah.
Program. We want to verify that yes, everything has run successfully, and
Yeah.
we will exit our program in success. So to do that, we will write move RDI, 0. So when we are moving 0 into RDI, it is freeing up the console, because in our previous message
I see.
RDI,
I see.
we moved 1 inside the RDI register.
Yeah, it would be fun to experiment with.
Profile.
I'm ready to experiment. Okay, so we have the program right here. Let's just wait. Why would we syscalling this again? That is not fun. I know why we're syscalling, but okay, just
our
wait a bit.
file, and when we save this program and we exit it,
I see. Okay. Let me just exit this, and yes, let's just now write NSM f64, which is the format of our program. This is first.asm and LD is going to link our program first.o. Did I miss something? maybe I missed something. Wait, just wait a bit. NASM F64 LDO test. Yes, I definitely missed something. F64 first.asm and LD-O. This would be first. This would be first.o. Yup. Now you can see that we have this first file. We also have two other files, which is first.asm and first.o. Ignore these ones because I was testing with this earlier, so ignore this one. We have basically three files: first.asm, which we first wrote the program in, right? Then there is a first.o file. Should I show you the first.o file? Let me show you the first.o file. First.o file. This is something like, what is this? This is basically an object file. So an object file is like an intermediate file that we as humans cannot understand, but the computer needs it to make the final executable file, and the final executable file is this first. So let me just run this first file. What's going on? No, come on. Yeah, first. And you can see hello world is printed here. But now let's have some fun. Let's go to nano first.asm. I am going to simply audio. Okay, let's just do one thing here. Let's just nano first.asm. Okay, let's execute first 2 times. So this is first. This is executed one more time, which is okay. This just prints hello world 2 times. Very good. Now let's just go into nano first.asm and let's just do some naughty stuff, which is let's just remove this file and let me see what this does. Okay, it's gonna be fun. We have to compile this again. To compile it, we're gonna write NASM FF64 first.asm and LDO first.o. Oh no. Yeah, that's one. Let's clear this. So let's run first right now. Yeah, it prints hello world. Okay, let's just print it another time. Let's say prints hello world. So yeah, what's going on? Let's ask Gemini. This is a common assembly optimization. XOR is a register with itself result 0. Yeah, okay, it's actually faster to compile. Okay, but why do we need to make the RDI register 0? Well, that's a valid question. Let's see. Come on, Google, give me the answer. Damn, every agent is slow today. Oh, I know why it's slow. It's my fault. I had to choose fast. You do not have to make it 0, but making it 0 is the universal signal for success. Okay, that's why. Here's the breakdown. Oh, yeah. Okay, I get it. Chain of command. Okay, so RDI is the exit code. The exit code for syscall number 60 operating system looks for RDI register to see how the command finished. RDI equals to I finished perfectly, no problems. RDI 1 equals to any non-zero, something went wrong. Chain of command, when program dies, it passes a number back to whoever started. Okay. So try it yourself. Echo test. Okay, so let's see. Hello echo $/ sorry, $? Prints the exit code of the last. Oh, okay. So echo $ and this. Try this right now. This will print 1, which signifies the code that it has not ran correctly. General error, misuse not found. Oh, I see what's going on. Alright. So now let's go back into Nano Fuzzer ASM and let's just fix what we changed. So, oh my god. Not move XOR RDI, comma RDI. And move 0 into RDI. Universal sign of program success. Yep. Okay, let's run this, compile it again in a SM. I'm not gonna write this again and again. And sorry. First, hello world. If I write echo dollar question mark, it's gonna save 0. Yeah. So yeah, we wrote our first language in assembly. We did some fun stuff. Now what can we do next? We can write some different programs. We can write. Okay, what I always wanted to do was take input in assembly, you know. So let's see how to take inputs in assembly. Okay, you know what? I'm just gonna come back in a while. I have to eat. Webcam group. Alright, I'm back. What's this? Notifications, news. Make sure you can access and call up. Yeah. Okay. Let's get back to writing some code. Alright, let's write a simple Python program for. Oh, I'm full. Printing our name. So it's gonna ask you my name. We have to give it an input. You're gonna print my name. Okay, so say name equals input. Enter your name. And I would say print name. I'm not gonna explain much here because you can ask ChatGPT and learn for yourself. Just kind of like exploring some stuff here. Writing in different languages. That's the fun of this session. Okay. So my name is Kingshuk. I did my name right. I don't know. Yep, and it has given me Kingshuk. For simplicity's sake, let's just write this. My name is, and then the comma and name. Yep, let's write here. Enter your name. Kingshuk. See, I wrote my name wrong. Who does that? My name is Kingshuk. Yeah. Okay, in C++ we can write the same program in like this. We can say stdc out, enter your name, and stdc in name. Now we need to write a variable name, which is, oh man, how do we take how to take my name as input and write it and print it in C++. I'm already feeling very sleepy right now because it's like 1:30 at night and I'm tired too, but let's explore some more. I'm having fun, okay? String name. Did we have strings in C++? I completely forgot. Alright. String name. Alright. And instead of writing cout in hello world here, we're gonna write my name is, and then we are going to write name. Let's run this program. String name. See, it's. Oh, we're gonna have to include this string header file. Hash include. Man, I'm writing C++ after such a while. I love it. What the hell? Wait, what's going on again? Yes, include string. Information string. String is not declared in the scope. Std string. Oh, I think we have to write this as std string. Yeah. Yep. Let's just write my name Kingshuk and print here. Okay. Let's do the same in C. How to do the same in C. I know. Reserve space for 49 characters. Okay. Okay, this one is interesting. Okay, let's start with this. Okay, so what do you have? A character name. All right. Next what? Printf, enter your name. Yup. Scanf. Yep, makes sense. Okay. Also makes sense. Makes sense to me, but yeah, it's a little hard to read for new programmers. Don't worry, you can learn from ChatGPT and enter your name. My name is King Shook. Hello, King Shook. Yeah, that's fine. I can say my name is King Shook. This will also run fine. However, if we write enter your name King Shook Shah, it's gonna write my name is King Shook because the Shah gets obliterated because there is a space here and this mod S only takes it only takes the input up till a space. So reads one word, stops the space. Okay, alright, no problem. Scanf stops at first space, so yeah. So if you want to read the full name, space is included. Printf into your full name, fgetS. This one is a bit tougher as a syntax. So you have to write fgetS name, size of name, and then stdin. Okay, so stdin is for standard input. And then nice to meet you. Gives the new line character so outperformed safer and complete way. Okay, let's see how it prints that. So on this, enter your name, King Shook Shah. Oh, look at that. So we can't write this here. Okay, so my natural question would be, so doesn't it print all 100 characters? How does it know where to stop? You press enter. Oh, I see. Is there a way to initialize the character array with exactly the length of my name? You can, but there are two different meanings hiding in your question. You already know the name at compile time. You want to set size I want to set the size dynamically based on the user input. Just copy this. I want to. Ouch. Serving integer dynamic memory allocation, which is C, is equivalent of building a room only as big as person walking into. Yeah, of course. So allocate just enough memory using malloc. Okay. stdleap, stdstring, main character buffer, temporary storage. Enter your name, size of buffer, stdin, better buffer. What is this remove training new line if it exists? strcspn. What is this? What is this? That's true. String complement span. In plain language, how many characters in the string occur before first appearance of any character from another set? Saying the new line character n in buffer and replace with a null terminator. Ah, I see. Okay, because fgetS. Yeah, I know what's going on. So, how many characters in a string occur before first appearance of any character from another set? I'm confused about this. What does this mean? Ouch! My head is hurting. Extend is how STS1 decides how to stop counting the function takes two arguments. Yeah. String to search set of characters to stop it. It works through the first string one characters at a time. It keeps counting as long as the current character is not the second string. Oh, I see. Okay. Ah, alright. Alrighty. Yep. So we're doing this buffer of goes to null. Yeah. Okay, I get what's happening here. But what does this return, this function? What does it return? And why don't they... what is the return type? What is the return type of strcspn? String complement something. I don't remember. String complement span, yeah. So I think this is going to be integer because that's the most probable thing. But let's just check once. This must be non-negative integer, but simply it represents a non-negative integer. What is it return type? What's this? So it returns a number of characters you can read from. I don't want to know its return, man. I want to know its return type. I think it returns unsigned int. Yeah. Okay, alright. So okay, let's just go here. Get name Malak. String buffer +1. Okay. Of course. I'll get the exact size needed. +1 for. We are saying that. Wait, what? Why though? In previous line we are already saying to replace the /n by 0, then that must be then why are we taking one extra space? You're noticing the invisible bookkeeping with strings. Two different things are happening here, so let's separate them. This yeah, so buffer so C string. Okay, yeah. Next speed needed here. Edit buffer is already had room. +1. This is a different purpose. We are creating brand new string in memory, so S string buffer counts this. Edit before. Okay, so for show it returns 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So, proper C string. Nice, yeah. This is a different purpose. We're creating brand new string in new memory. Counts the character. I see. That is very interesting, right? Because this what do you call it? The string len counts. It doesn't count the null at the end. So again, we have to enter a null, an extra character at the end. This is a pointer, name, string copy, name buffer. Okay, printf. Your name is. Yep, absolutely. Okay, but although this program uses dynamic memory. Wait, did I unmute myself? Yeah. Memory allocation. It still uses 200 characters. Can we use just the number of characters in that are my name, so no extra space required. Let's see what ChatGPT outputs. Yes, that is exactly how you start thinking like a system programmer. Yeah. Okay. So here's a manual version of how does that exactly work. You do it by reading input character by character and growing memory by realloc. That's really interesting. So hash enter std ios std lib character name equals null and size equals 0 and ch equals something. Printf enter your name. Okay, let's start writing this program. Okay, so we're also going to use /include stdlib here, and again, you don't need to write this. I'm just writing because I'm old school and I like writing programs. Okay, so can name equals null, remember if null is in capital. Yeah, null is in capital. Yuppie. Okay, size equals 0. I don't know what the use of size is. And size equals 0 and ch. Okay, let's see what's going on next. Printf into your name. I'm not gonna write this. Just copy and paste. While ch equals getchar and ch equals to getchar not equals to /n and ch not equals to eof. End of file. Okay. So this one is a bit character. This one is a bit tough to understand. Explain. See. One of the simplest input functions in C. It reads exactly one character at a time from the keyboard. Think of it as a tiny robot. You use it to press a key, hands. Yeah. What does it mean? C equals get call. Yeah. Okay, I get it. So this says that while ch equals to getchar. Getchar ch equals getchar. We're saying that ch equals to getchar. Call getchar, wait for the user to type something, store that type into the value of the variable ch. I see. Okay, and it's saying that if this, of course, getchar is going to be in parentheses. Is not equals to /n. Oops. Yep. And ch not equals to eof. So eof just means end of file. Ch equals to not equals to. Oh my god, I can't type. ch not equals to eof. Yep. Okay. So it said name equals to realloc, which means reallocate name size +1. What is name? I see. Name is the pointer and reallocate is memory size +1. Alright. Okay. Name equals to name equals to realloc name size +1. plus 1. And then there is what? Name of size equals to ch. Okay, let me first see what's the return type of this. What is its return type? Realloc transfer pointer. Realloc gives you generic pointer to a newly allocated memory block. Ah, I see. Okie dokie. Okay, so my next question would be, so then what happens to the code pointer? Right. Succeeds or fails. It's supposed to behaves like a realloc succeeds. Two things happen internally. There is enough free space after the existing block. Memory goes in place. The pointer value stays the same. There isn't enough space to allocate a new block somewhere. Copies the old contents, frees the block, automatically returns a new pointer address. I see. And if it fails, nothing happens. The original block returns null, but the old pointer is still valid. Okay. If reallocates returns null, then name becomes null. You lose the original pointer. Bad if reallocate fails. And now you cannot free it. That's a memory leak. Okay. Let's see if this is going to cause like memory leak. So let me allocate. Is this? Can this cause memory leak? Yes, that exact line causes memory leak. Okay, so see, this is a very good example that ChatGPT doesn't always give you the very safe, very good code that you expect from it. It is not a very, good programmer. It's better than average, not good. And this is what I think, that learning from ChatGPT, it's easy, but it's not the same as learning from a teacher. There's difference. Okay, so temp equals reallocate. Yeah. So here I'm not gonna write this. I'm actually gonna write temp equals realloc name size plus 1 if temp not equals to null, name equals to temp, else I missed something. Else what? Just give it a print statement like something like this. Maybe reallocation field or something. Reallocation field, yeah. This doesn't happen, but it's a good version. It's a good practice. Reallocation field. I have wanted to write C code like this for a while. Oh. Sorry, temp. Yeah, sorry. Now, after this, what we are going to do is This name reallocate size. Name size equals ch. Name of size, which was 0, right? Okay. That makes sense. Name of size equals ch and size plus plus, right? Yeah. Yep. Size plus plus. And num terminator name equals to reallocate name size plus 1. Okay, again we are going to check if this can cause memory leak. I think it's gonna say yes. Yes. Alright then. We can copy this code over here. Save temp because name size plus 1. Yep, and then say what do we say? Name of size. Name of size equals to null. Yep. After that, we don't have to do size plus plus, and printf your name is this. Oh, sure. It's gonna be fun. Printf. My name is mod s and then /n and printf bytes used mod d bytes. D bytes, and we write right here size plus 1, right? Yep. And this one we write name. I think name. Yuppie duppie. String. Okay. Let's run this program, and we have to do a semicolon here. Let's just run this one. 14 bytes. Wow, we did it. We did it. We did it. That's good. Okay. Now for the I wanted to run this in my nanofuzz.asm. Let's just write this here. Let's run this program. What is this guy saying, man? Main.s. Something wrong with the assembly here. I'm not doing this. Okay, what I wanted to ask is that input name, okay. Why is this code? Sorry. Why is this code faster than MOV RDI 0? It's gonna be an interesting one. Historically, XORDI is faster because the CPU used 0 idiom optimization while MOV didn't. What's that? At the long enough animation, when you write move idea 0, you're loading an immediate constant at the register. CPU treats like a normal write. It has to decode the constant, schedule execution, and actually write the value into a physical register. Yep. Does something sneaky. CPU sees you are XORing a register with itself. It knows the result will always be 0, so many modern CPUs treat this instruction 0. Alright. Is it depends? Okay. That is fun. That was fun. Okay, I think I'm gonna stop here. We can continue later. So yeah, goodbye. Have a good night. If anyone's